Hello guys and welcome to another lecture in differential equation. Right now we will be moving forward on other integrating factor techniques that we can use in solving for our differential equation. No? So as our goal for today's lecture, outline natin is to recall what we are doing when we are testing for the exactness of the differential equation. Then we will be discussing the table of integrating factors, and then we will try to solve a problem pertaining to this topic. Okay? So learning outcome natin are as follows. To identify the integrating factor required using inspection, to familiarize with the use of the table of integrating factors, and to solve problems using integrating factors by inspection. Okay? So to recall, we pertain to the function that we try to multiply with our differential equation as the integrating factor, no? And then we do this once we prove na hindi exact yung mismong equation natin, ano? So there are actually 6 methods for the concept of integrating factor, wherein yung exact equation is already discussed to you on the previous lectures. Also, we already discussed or cover yung linear equations and Bernoulli equations. So for today, we will be discussing another method to reinforce yung knowledge niyo with the solution for finding out the integrating factor for suited for the differential equation. Okay, so um, yeah. So we have yung exact equation. So to recall, we test it for exactness, and we do that once we identify the function m in terms of x and y and n in terms of x and y. Then we try to get the partial derivative of m in terms of y and partial derivative of n in terms of x. And then once these two values are equal, we say that our differential equation is exact. Okay. Once we prove that it is exact, we can actually solve the differential equation using this step. Okay. So to review or to know more about this lecture, please refer to the other lecture video about exact equation. Okay. So what happens now if our differential equation, once tested for exactness, is not exact, or the differential or partial derivative of m with respect to y is not equal to the partial derivative of n with respect to x? What will happen? So it is said here that it is possible to transform the non-exact differential equation by judicious multiplication. Okay? Judicious multiplication meaning we are trying to introduce now yung integrating factor. Okay? So we say judicious because this particular method is dependent on the capacity of the solver on how he understand yung mismong equation natin, ano? So judgment siya nung mismong nagso-solve. So um, it is quite difficult if you're not very familiar with yung tinatawag natin exact differential, or even um, not very good in differentiating functions, no? Kasi uh, certain equations are not easily identified as the differential of a given function, ano? Kaya this is based from the experience of the solver. If nagso-solve kayo frequently before ng differential calculus ninyo, and then if you are trying to solve the other concept or other methods discussed prior to this discussion, um, dito matetest yung knowledge nyo with differential equation, ano? And as you can see here, based from our standard equation for differential equation, we can actually solve the differential equation once we multiply the integrating factor that we will try to identify using inspection in this lecture. Okay, so to help us decide um, the right factors to multiply, we have what we call table of integrating factors. Okay, so these values actually are, if you want to be better in solving differential equation, you should memorize this. Okay, pero I am not obliging you to do that. Siguro just focus on some, maybe on this particular um, five rows or five items. Okay, and then for the rest, we can actually just go back if we need values pertaining to this exact differential. Okay, so ang job natin is to use this table as a guide on what integrating factor we will multiply on our given differential equation. Okay, so um, how can we do this? We can select which integrating factor to multiply once we see this group of terms dun sa differential equation natin. Okay? So later we have an example. Then we will try to identify which integrating factors are possible. Kasi hindi lang isa ang pwede, no? It can be a number of solutions that eventually will yield to the same answer after you have multiplied it with the different integrating factors available for you. Okay? So for now, we will just leave this. And then we will try to cover what are the particular steps that we need to uh, be aware of when solving for the integrating factor by inspection. Okay? So here is the suggested step to follow. So this is just my personal um, step-by-step procedure. This is not available or can easily be seen on other books or textbooks. So maybe you will develop some step in the future. But for now, let us try if we can work with this suggested step to follow. Okay. So step one, once you see the differential equation, we need to regroup the terms strategically. Okay. Why? We need to regroup them kasi sometimes yung differential equation natin, as I've mentioned earlier, it is not easily identifiable if we can solve it talaga agad-agad, ano? Kaya nga dito sa table of terms natin, we are pertaining, meron tayong mga group of terms, okay? So, ang pwedeng goal natin, mapalabas natin tong mga group of terms na to para dito na lang tayo pipili ng integrating factor. Okay? Kaya yun yung goal, kaya nagre-regroup tayo. Then after the grouping, yan, refer daw do sa table of integrating factors and look for possible multiplier na IX or integrating factor natin. So again, it is possible to have an integrating factor or a multiplier na greater than 1. Okay, it can be a 2, 3, or 4 multipliers na eventually once you solve it, will yield to the same answer, no, or conclusion. Okay, then after you select some of the possible multiply one by one to the given differential equation. No? So you can decide whichever is suited dun sa differential equation mo. Again, you can only decide this once you encounter or you have solved a number of problems, no? Pero tingnan natin ano on our example if we can identify some. Okay, the number four, solve for the differential equation and get the solution. Okay, so that is the main goal of our subject. Okay, so to get the solution for the given differential equation. Okay? So to um, proceed with our lecture, let us have this particular example. Actually, this is just one example for this video, introductory video, to show you how to use yung table of integrating factors natin. Okay? So for our given equation, we have y dx minus x dy is equals to 0. So we cannot do anything anymore. It's already in its simplest form. We cannot regroup it to um, another way, no? Kasi two terms lang siya. So, allow me to just copy the table so that we will not go back and forth lagi, no, dun sa lecture natin. And also yung step, no? Allow me to copy the step so that um, we can just refer to it here on the same page. Okay. So, again, for this particular example, yung step 1 is not applicable na or already ano na siya, no? Catered na siya. So, we don't need to regroup our differential equation. Step 2 now. So, okay. So, I will just put here step 2 is, as mentioned here, is look at the table of integrating factors and look for the possible multiplier. Okay? So, ito yung ating group ngayon, ano? Doon sa first column, doon sa table natin, as you can see the same grouping. Y dx minus x dy. Based from this group, we have this, we have this, we have this, and we have this. No? Actually, four agad, no? We have four different rows that are having the same group of terms that we have here. Okay? As stated dito, ang magiging integrating factor daw natin are these four values. Okay? And then, once we will multiply that, kapag nakakita tayo ng ganitong value, pwedeng daw natin makuha yung exact differential niya. Okay? Meaning, yung equivalent differential of the given function. Na kasi nga, once we integrate, this function is just uh, being canceled out or nilalabas lang natin siya dun sa integral sign, ano? Based from the property of integral or integration formula or basic differentiation, number 1. Okay? So, ayan. So, we have, okay, so allow me to write the possible integrating factors. So, we have, according to the table, we have negative 1 over x squared. We have 1 over y squared. We have negative 1 over x, y. And we have negative 1 over x squared plus y squared. Okay, so let's check if it's the same. Negative 1 over x squared, y squared, negative xy, and negative x squared plus y squared. Okay, yeah. So yan daw yung mga possible integrating factors natin. So once you have that, proceed to number 3. Multiply the integrating factor to the differential equation. Okay, so ang ang gagawin mo dito, one by one mo siyang i-multiply, no? So again, you can actually just choose one from these four. Pero for the benefit na ma-demonstrate siya sa inyo, we will try to solve, let's try to solve it all, ano? If we will arrive with the same answer. Okay? Okay, so let's start with an integrating factor of value na negative 1 over x squared. Okay? Again, the integrating factor is i-multiply natin dun sa given na differential equation natin. Ayan. So, let me copy the given y dx minus x dy is equals to 0 multiplied with negative 1 over x squared. Okay? So, once we do that, we have now, so the numerator, so y dx minus x dy over x squared is equals to 0. Distribute the negative 1, we have y dx negative plus x dy over x squared is equals to 0. Okay, moving on. Rearrange the term. We have x dy minus y dx over x squared is equals to 0. Okay, so when you go back to sa table, as you can see, you have already written the same form na nandito. No? Ayan, ito yun, no? X dy minus y dx over x squared. So once you have this quantity, exact differential daw niya is y over x. Okay? So meaning, this can be equal to dx over y over x. Okay? Is equals to 0. Okay. Ano ba ibig sabihin ng differential? Differential actually, exact differential. So ibig sabihin, pag dinerive mo daw si y over x, so derivative of quotients, we have derivative of, we copy, um, pag derivative ng quotient, we have u over v. So that is v du minus u dv over v squared. So dito, yung ating y is ang ating u, yung x natin yung ating v. Okay? So, derivative of, we copy dito, yung v natin is si x, du natin is dy minus y dv over um, x squared. As you can see, this value is the same nito. Kaya siya tinawag na exact differential. Okay? Now, once you have this, you integrate both sides. Okay? So again, once you see an exact differential inside an integral, mangyayari dyan, ilalabas mo lang siya. It will be y over x is equals to c. Okay? Or ang final answer natin is y is equals to c times x. So this is our solution or required solution for the given differential equation. Okay, so that is for our first integrating factor. Okay, so ayan, so si number 4, allow me. Yan, dito na pumasok si step number 4. Okay? So that is for the first one. So okay na tayo dito. So first um, integrating factor natin. Let's try another one. Okay? Yung y over 1 over y squared. Okay. So integrating factor natin is equals to 1 over y squared. So we have y dx minus x dy is equals to 0. Multiply both side by y, yeah, 1 over y squared. So we have the numerator y dx minus x dy all over y squared is equals to 0. Okay? So dito, kailangan mo na ngayon i-check if you have an exact differential, no? So dito, makikita mo, naka-square yung y. If you see something like that, dapat automatic maisip mo na agad na may nangyaring derivative of quotient, no? Pag may derivative of quotient, di ba, yung naka-square sa ilalim is yung v niya, no? Dito. No? Kung halimbawa u over v yung dito. So, ibig sabihin, pwede ang nasa ilalim natin is y, and then eventually si x yung nasa numerator, no? Now once you try to derive that, that is y dx minus x dy over y squared, applying quotient rule. So this value is the same itong value to. Therefore, d of xy over y is an exact differential of this function. Okay? So we have d x over y is equals to 0. Then we integrate both sides. We have x over y is equals to c. Okay? Or Final answer natin is x is equals to cy. Okay? So, is it the same as the previous one? This is the previous one. We have y is equals to cx. Okay? So, if you try to divide this both side by c, we have y is equals to 1 over c x. But since this is an arbitrary constant, we can actually say na that is c2x, which is the same nung ating previous solution. Okay? So, ayan. So, another integrating factor that we have, then, ayan. So, we are also check dito, no? So, are you convinced now that actually all of them are possible, no? Okay. So, let's try the next one. Okay. So, that is negative 1 over xy. Okay. So, ix number 3, negative 1 over xy. So, y dx minus x dy is equals to 0. Okay? And multiply daw natin with negative 1 over x. Okay? So we have negative 1 y dx minus x dy all over xy is equals to 0. So we have negative y dx plus x dy over xy is equals to 0. Okay? So what do we do now? So what So, pwedeng algebraic naman tayo. So, this is negative y dx over xy plus x dy all over xy is equals to 0. So, magka-cancel out to. Cancel out to. So, we have negative dx over x plus dy over y is equals to 0. And then perform natin integration. We have negative, that is ln of x plus ln of y is equals to c. Okay? Now, once we have that, or to make it um, convenient, gawin natin ln of c din. Beside arbitrary constant naman yan. Then, applying yung ating property for natural logarithm, this can be rewritten as ln of y over x, okay, is equals to ln of c. Okay? Once we have both a natural logarithm both side, you can actually remove them together. It will retain equality niya. So y over x equals to c. Eventually, y is equals to c times x. Again, this is our answer before. So we have the same value as the previous two solution. Okay? So, yeah. Then last, we try the last one, negative 1 over x squared plus y squared. Okay, 4. Negative 1 over x squared plus y squared. Okay, so we have y dx minus x dy is equals to 0 multiplied by negative 1 over x squared plus y squared. Okay, so we have negative y dx minus x dy over x squared plus y squared is equals to 0. Distribute, we have negative y dx plus x dy over x squared plus y squared is equals to 0. Okay? So, how come hindi siya pwedeng i-separate for both, no? You have to understand na this is composed of two or more terms, kaya hindi siya pwede what we have done dito sa previous one, ano? This is a single term, no? Monomial to. Kaya pwede natin siyang i-distribute or i-separate with each term dito. Okay? Kung isa-separate natin, ito, dapat ito yung first term, ito yung second term. And we cannot do anything about it. Okay? So, kaya retain lang natin siya. Ayusin lang natin yung numerator. We have x dy minus y dx all over x squared plus y squared is equals to 0. Okay? So, what do you think is our answer now, no? Once you go back doon sa integrating table of integration natin, okay? Once you have this daw, ano? Okay? Equal daw siya sa exact differential ng arctangent y over x. So, let's check kung this is the same, no? So, let's try to crop this one out. Ayan. And then, go back dun sa previous slide natin. Ayan. So, ito. Okay? So, let's check if we have the same, ano na, no? Condition. Ayan. So, is it the same? So, x dy, y dx, yes, no? So, this can now be equal to the arctan of y over x is equals to 0. So, if you are still in doubt, how come na equal siya dito, you just need to derive this, no? And then eventually we'll have the same value as this one, no? So, go back to differential calculus to verify if the derivative of arctangent y over x is the same as this one, okay? And then we perform integration. So, we have arctangent of y over x is equals to C. Okay? And then arctangent when inversed ulit, that will be y over x is equals to tangent of C. Okay? And this will be y is equals to tangent of C times x. Again, since tangent of C can be any value, so we can represent this as another arbitrary constant, no? So our final answer will be y is equals to c2x, which is the same with our previous three solutions. Okay? So with this example, we have proven na although we have identified four possible integrating factors, we can use dun sa differential equation natin if done correctly, you will or you should arrive with the same answer. Okay? As seen with these four answers na we have on this particular problem lang. Okay? So, I leave this problem for you to digest, to review, and then this ends our lecture for this topic. Okay? So, I have succeeding videos solving some other examples, so please check out for that. Thank you.